All right, friends of mathematics, we're talking about Math 105, section 2.5, and we're going to deal with only function composition today. And so the dream of function composition is to use the output of one function as the input of another. And I have three functions available to us. F, which is given as a graph, not really scale-ish, but that's okay, you can live. I have G, and I have H. And the idea is if I gave us something like this, H of F of 2. What we're doing is I'm going to put 2 inside of F, and we're going to get 1 out. And so the output here, that's F of 2 is equal to 1. And we're going to use that output as the input for H. And when I put that in here, 2 divided by 1, we get 2 out. And that is our solution. Let's go again. And this time we're going to pick, how about H of F of 3? Sweet. Not a great stretch of the imagination. And we can see that I can plug 3 in, and we get H of 0. But now we're in a world of hurt. It turns out if I put 3 in, then I'm going to have a problem. And so it turns out that 3 is not in the domain of H of F of t. Now, just so you know, we would have 2 divided by 0, and we would get excommunicated by the Church of Math by dividing by 0. Yes? Let's go another one here. What if I did something like G of 1. And the idea here is first I'm going to go G of 1, and the output of G of 1 is going to be the input to this other G function. So G of 1 is 3. And now G of 3 gives us that joyous 0. So I can compose more than 3 times if I wanted to. I could say something like H of G of F of 1. Okay, so let's just slow our roll. And I kind of like that vertical approach. Let me make sure my parentheses all work out. So now I'm using F of 1, and F of 1 gives me that glorious 2. G of 2 gives me 1. And finally, when I put 1 into H, we're going to get 2 divided by 1, and we get 2 as our solution. So we're going to continue our 105 discussion in section 2.5 function composition. And I've made 2 functions for us. We have R equals F of t, and that's going to be the total number of inches of rain on the 10th day of a growing season. And we'll let M equal D of R be the number of pounds of vegetable grown after our inches of rain have fallen in a season. And while on the previous problem, we were just putting things however the heck we wanted to, right now, if I'm asking you to compose these functions, I think they only fit in one way. If I was to say F of D of R, the output of D of R is going to be some number of pounds. And that output does not agree with the domain of F of t, which is the days of a growing season. So can I compose it the other way? Can I say D of F of t? And let's just check if our units work. If I put some t value in, that'll be the day of the growing season. And if I then output some number of inches of rain, I can put that into D. Now, I like to draw a little picture when I make functions like this. And so what I'll say is that here's the 10th day. And what F does is it brings me from days to some number of inches of rain. We can do the exact same thing with D, that we took in some number of inches of rain, and we outputted some number of pounds of veg. When I compose these things, what I'm really doing is I'm making a brand new function, d of f of t, that takes in days and gives us the number of pounds of vegetables we have. And so when I make an interpretation here, I am not going to mention this intermediary function. It becomes an artifact. So let's make an interpretation of something like d of f of, say, 35. Yeah? And we can say on the 35th day, on the 35th day of a growing season, d of f of 35 pounds of vegetables have been grown. I know that you're tempted to say that there's going to be some numbers of inches of rain and then some pounds of veg, but I've really made this new function, and so I've kind of covered up that thing behind the curtain.